Sooner or later, it's going to say this hangout on there is live. And the title of this video is F# Dependency Injection in Domain-Driven Design. And honestly, I kind of frown on the term dependency injection because almost every single time I hear that at work, it's someone trying to sound like they're really educated. They actually put a pause in between the rest of the sentence when they say dependency injection. I've always viewed dependency injection as a glorified name for passing arguments to a constructor. I mean, that's the way I view it. However, dependency injection appears to sound so fancy that just the name itself to newbies or novices, it shakes them, or it makes them tremble with fear. This dependency injection, it's something that sounds very, very advanced. And honestly, I don't think it's advanced. I think it's just another tool. When you dumb it down, in general, when I do quote unquote dependency injection, I'm just passing arguments to a constructor. That's all I'm doing. Right? That's all I'm doing. But industry wants you to believe that this is some sophisticated technique for enhanced testability. And it is a technique targeting enhanced testability, right? I just don't think it's that advanced. I would prefer that we, instead of saying dependency injection, we just say we pass arguments to a class constructor, right? Now, why am I saying class constructor? A class, that's object-oriented programming. Functional programming, well, that's a different paradigm. Well, yeah. In the last video that I did, it was wiring a view model to a domain workflow. And at the end of the video, I discussed the view models that I built. I qualified those view models by doing my own personal code review while I was live streaming. And at the end of the video, I ran my 2 unit tests for validation and for submitting a registration form. And lo and behold, my submit registration form test failed. And as I dug into it in the video, I learned that it failed because it was supposed to fail, because the module that I had that was responsible for doing web requests, by default, it just returned an error. And every IO operation that I had that is meant to talk to the outside world, by default, my default implementation just returned an error. And that was on purpose because I didn't yet focus on those implementation details of IO operations. And my tests reflected that. And my tests, they were supposed to fail, or that specific test was supposed to fail. So in actuality, the stuff passed because it was supposed to fail. Even though the tests were red, that was ultimately what it was supposed to do, right? So the reason why the test failed was because, again, it was doing IO, and the IO wasn't yet implemented yet, and by default, it returned an error. So after I finished the video, I went ahead and made those tests pass, specifically by providing a mock implementation of IO. And that's what, in this video, I will attempt to articulate. This is me practicing out loud domain-driven design made functional by Scott Vlashin's book. And so maybe I could share my screen. Come here, I'm gonna share my screen. Yes. Share my screen. Google Hangouts Explorer. I don't know if I want to do that. Share my screen. Screen share. What just happened? Am I sharing my screen? Present to everyone. Yes. And okay. So hopefully it says that I'm sharing my screen. So what I want to talk about is if I go to my view model, come here, view model. That's not the view model I wanted. If I go to but I could go to the definition right over here. Come here. If I go to my view model, let's collapse everything for right now. Collapse everything right now. Oh, how do I collapse everything? I thought Control MO was collapse. Is it Control ML? No, Control ML expands everything. Control MO. That's weird. Why is this type view model collapsing? All right. Anyway, so to review, I wrote this view model right here. Okay. This is the view model that I wrote. Let me kill that window, kill that window, kill that window. This is the view model that I wrote. Okay. View model has a validate command, which is found right here, and it has a submit command. Okay. The validate command is pure domain logic. The submit command relies on IO logic. Okay. We expand that submit command and it says submit over here. We go to the submit definition over here. And it says this validated form. Do we have one? If we do, then great. We take the form from the validated form and we basically run that through a command.execute. And then we pipe the results to in submit registration.workflow and we say submit function. The submit function is new, right? The submit function is actually the implementation details or the function that we want to pass to actually do the operation. So what I'm saying is in submit registration.workflow, we're actually passing in the function that is going to perform the actual submit operation. Okay. That function could be a function that relies on HTTP to talk to some external system, or it could be a mock submit function in which it doesn't do anything with the outside world. It's just mocking the actual submit, and it's still handled within our domain, but in this case within the test. So actually not within the domain, but this submit function could also be a test that does a submit. And then the result of that, we take, which are events, and we publish these events. Let's publish events. We'll basically say, hey, an event occurred. Here's the event right here that occurred. And whoever subscribed to this view model will go ahead and receive that notification that the event occurred. In this case, I know that my navigation is subscribed to this view model. And it says, hey, I want to subscribe to event occurred. Here's the function handler that I want to respond with. It receives that event. It takes that event and it basically uses that event to generate a page request. So event pipes to page, which pipes to request, and the pages are registration succeeded, registration failed. Right. Well, those are the events. If the registration succeeded, then we say page requested.portal. If the registration failed, we say page requested.error registering. Okay. And then this request over here is going to rely on Xamarin Forms to do some actual navigation somehow. And that's to do, okay? So if let's go back to a view model. As I said, to do quote unquote dependency injection, the reason why this implementation needs it, this solution needs it, is because I still want to be able to write an automated test. And I want to test the actual business logic. I'm not yet interested in testing integration logic, right? Now, I think in the book, Domain-Driven Design Made Functional, it advocates that I/O is done on the edges of a workflow, which I believe I did correctly. And the book says that if you have I/O at the edges of a workflow, then testing probably should be considered trivial, and that you can, if I/O is on the edges, then you maybe don't need to be as concerned with unit tests, but there may be more value in integration tests because your I/O operations are like at the very edge, and 9 times out of 10, it's just going to work, right? I think that's what the book was kind of advocating. Okay, that's fine. But in my case, I like having fast automated tests. Integration tests, they're slow by orders of magnitude. And so I rather have the best of both worlds. I want to have my cake and I want to eat it too. With that said, earlier I said dependency injection to me is a fancy term for just providing arguments to a constructor, in which these arguments are, well, dependencies. Dependencies can be implementation details, or let me change that. Dependencies can be strategies for executing certain pieces of code. That strategy could be code that actually relies on I/O, or it could be an alternative piece of code that instead of doing some I/O operation, it mocks an I/O operation, right? That's how I use quote unquote dependency injection. And I usually do this by just passing that dependency or that strategy that I want into the constructor of a class, in this case, a view model. And I would like to put emphasis on strategy, right? It's, to me, is very similar to the strategy pattern where we have more than one algorithm to choose from, and based on the states of our, well, in this case, I'm going off on a tangent because it's not really based on the state of our system. So it's not really a strategy pattern, but we are using a strategy to execute some code. So I butchered that, but this is me practicing. This is the whole point. It's me practicing out loud. Anyway, so here's the submit function, and it is actually of type try.submit function. Okay. That submit function, I don't know, should I call it submit strategy? In submit registration.workflow, should I call it implementation? That may sound better. Implementation, I'm missing the N. something like that, implementation. And so if we looked at that, we say validate, we do pattern match on a validated form. If we do have a validated form, then we take that form, we pipe it to command.execute, and then we pipe that into the results of that into in submit registration.workflow, and we have this implementation, and then we publish the events. Okay, so that's at the basic level, not at the root level. The root level I'll show a little bit later. The root level is, in our case, going to be our actual automated tests that we inject these dependencies into the view model. Before I show that, I want to show what this actually looks like. So in this submit registration.workflow, in which we provide the implementation that we want to execute, should I call it implementation or should I call it strategy? I don't call it implementation. Or should I call it strategy? I'm going to call it implementation. Or should I call it strategy? I don't know. No, I'll leave it like that. So here's our, let me close out everything else. Okay, if I do control MO, it should collapse everything. Okay, so in the submit registration that workflow, which is right here, how's this work? Am I looking at the right thing? I am looking at the right thing. All right, so in this workflow function of our submit registration, which is up here, we see our function type. Our function type is submit workflow, and it takes this try.submit function, and I'm thinking I should probably call that implementation. Try.submit implementation, maybe. I wonder what that looks like. If I do that, then that's going to make the name really, really long. Not sure if I want to do this or not. Try.submit implementation. That's a little bit harder to read. We'll stay with function. So we have this try.submit function, okay? And why does it still have a squiggly? We try to build, the build succeeds. Okay, so not sure why it has a squiggly, but the build succeeds down here. This workflow will take our submit. How's this work? The submit is the actual, let me start over. The submit workflow will take our submit function, and we'll also take the command, and it will output a list of domain events, specifically registration submission events. Okay. The submit function, this should really be, to make it clear, I take this submit function and command, these are the parameters. With that command, we do pattern match, and there's only one item that it could possibly be, which is a command.execute that takes a form. That form we pipe into the submit function, okay? The result of that submit function, we pipe into result of .submit.executed our registration submission events, okay? That's going to emit a list of domain events that ultimately, in our view model, we publish these events, which are navigation. Take those events and it performs navigation based on the events that were outputted. So that's the way it's implemented within our workflow. And if we look at our submit function, if I do F12, it's not going to do anything, right? But the submit function actually, if we look at this submit workflow, no, let me start over. If we look at this submit function, we see that the submit function takes as input a validated form, right? Because we're submitting our registration. So it takes a validated form type and it outputs a result. If it's successful, a profile. If it's not, our validated form, okay? Now, if we also observe, we see that we have a function that adheres to or a function that complies with this submit function type. Okay. So this is in our profile bounded context right here in our try.fs file. So this try.submit, which is this right here, module try.submit, is going to take the validated form and it's automatically just going to return an error form. All these functions right here is our IO, right? In which I haven't actually implemented the actual web request. So by default, I'm just returning error for everything: error form, error unit, error credentials, error profile for all these relative IO operations such as save, log in, log out. Okay. And right here, this is submit. We're submitting a registration form. Okay. In fact, this might sound better if I just call this registration. I think that's more readable. Okay. So submit registration, login, credentials, save, profile. All right. So that's our actual IO implementation, which isn't much. We just returned errors. But we also have this submit function implemented another way, right? We have an alternative strategy. The submit function, let me see if I do actually I should be able to do a shift F12 to find all references. And hopefully if this preview version of 2017 Visual Studio 15.6, hopefully it'll show our example-based tests. Let me see. Yeah, in our example-based test, there's a reference to submit function. And we have a mock submit that also outputs type submit function, in which that submit function will take a registration. And let me line everything else up. And it's going to, for testing purposes, I just say okay, and I just provide whatever fields that are empty, which is a profile. Okay. I probably don't need this over here anymore. Something like that. This data transfer says it's not necessary. Sure you're not necessary? I try to build everything. And everything builds. Okay. Actually, I'm not using registration, so I could just go like this right here for the mock part. And because if I'm not using it, then I don't want people to focus on it. It's just noise. Uh-oh, I didn't mean to do that though. So let me align these things back, bring it back. That's happy. That looks like it's happy. Okay. Now, I showed the mock submit implementation, and I showed the IO submit implementation. Okay. Now what? Well, now should I just call this Zmodel dot? Should I still call this try.submit or should I call this io.submit? Well, I think IO is probably better now. Well, no, I'll leave it at try. Try says that it can return an error. Okay, if it can return an error, then that will lead someone to believe that it's IO dependent, or it could be IO dependent. So I'll leave it. All right. So with that said, I showed the IO submit function, which isn't much, or should I say implementation details. I also showed the mock submit implementation details. Now, with that said, I can show the test, which is this right here, my registration test. Control MO, collapse everything. Registration, there's a test called registration submitted after being validated. I expand that. We will see that I have a mutable value called registration succeeded that I'm actually going to do verification on later, okay? As a result of doing the submit operation or the registration.submit command. That's the actual test. Registration.submit.execute, which I plan on it ultimately triggering a registration.event occurred, in which we modify this registration succeeded mutable value to be true if this code is executed, if that event did occur, and that event is of type registration succeeded, okay? In order to make this work, our registration view model, when we instantiate it, we pass in as a dependency, hence dependency injection, as I repeatedly said, is a fancy term for passing arguments to a constructor, okay? We pass in our mock submit function, okay? Mock submit function is this right here, remember? Where we just say it's going to be a result type of okay, and here's the profile details of that okay, right? That's what we're doing right here. We say let registration equal view model, and the constructor of that view model, we're going to pass in the mock submit function. And this mock submit function is used in our workflow. So when we go to our workflow, as I attempted to articulate earlier, our workflow takes a submit function. It takes a command, it returns a registration submission event list, okay? That's the function type that it has to adhere to. And we see here, submit function, command. When we say command.execute, there's a form that we want to attach. We say form, and then we basically pipe that form into the submit function, which could be the implementation of our mock submit, or it could be our actual IO submit. That depends on runtime. Regardless, it has to be a function that adheres to this submit workflow function type right up here. And then the result of that function being executed, whether it's in our example-based test or our actual Xamarin Forms application, we're going to basically return those events. The events is either going to be registration succeeded or registration failed. And we look in our test, we do pattern match on registration succeeded or registration failed based on those events that were published, which we could see. Where's the view model? The view model has when that workflow returns the domain events, it calls publish events right here. And that's where we have event occurred.trigger, and we provide the event, and whoever subscribes to this event occurred, well, they're going to receive that event, which we see over here in our tests, where they received this event occurred. This is the event right here. We pattern match on the event. Did it succeed? Did it fail? Let's update a value with that result of it succeeding, and then we do a verify on registration. Registration succeeded should equal true. And if I run the test down here, this registration submitted and registration validated, they're both going to be green. And it's building everything before it runs the automated tests. And sooner or later, everything is green bars. Yes. And that is it. So that's me practicing domain-driven design made functional. This is me thinking out loud, code reviewing my code out loud, so things sink in better versus me doing it silently, and I'm just doing it openly on YouTube live stream. And this whole video is me describing how I practice dependency injection. I hate that term within functional programming. So yeah, I think this video went so-so. It went okay. But the next time I attempt to explain to someone dependency injection in functional programming, then because this isn't my first time explaining it, it's going to sound more coherent. And that's the whole point of me doing this, is practice, practice, practice. So that's it. Adios. I'm Scott Nimrod. I'm looking for my next contract. I do mobile app development. I do desktop app development. I do back-end development. And keep me in mind when opportunities come across. All right. Say, hey, I know somebody. He's C# and he's also been going really deep into functional programming, specifically with F#. He even has a little application written in Elm, which I haven't looked at. I haven't looked at in the case of the IO in like a week. Anyway, that's it. Adios. Te veo a ratito. Yeah.